Day 13 of solving math problems in C until NVIDIA hires me. Part 2. So in the last part, we looked at this problem, where we have to find the number of unique routes from the top left to the bottom right of a grid, being only able to move right or down. So for example, in a 2x2 grid, there are 6 unique routes that take you from the top left to the bottom right, only being able to move right or down. And we have to find the number of unique routes for a 20x20 grid. In part 1, we saw how we could solve this problem for small values of n using BFS. And if you haven't watched part 1, I highly recommend you do so before continuing with this part. Now we can solve this problem much faster using combinatorics. Every unique path is just a combination of right and down moves. For example, every unique route in a 2x2 grid is just a combination of 2 right moves and 2 down moves. Or to generalize, every n by n grid will have a total of n distinct right moves and n distinct down moves, totaling to 2n distinct moves. Now, since we know there's a total of 2n distinct moves in a unique route, and n of those moves have to be right moves, then we can just assume that the rest of the moves will be down. So we can use the binomial coefficient to find the number of ways we can arrange n right moves in a sequence of 2n moves. So here's every way we can arrange 2 right moves in a sequence of 4 moves. And we don't have to check how we can arrange our down moves, since we know that if we have 2 right moves, we can assume that the other 2 moves will be down. So if we want to use the binomial coefficient on our 2x2 grid, we want to find the number of ways we can arrange 2 right moves in a sequence of 4 moves, which is equal to 4 factorial over 2 factorial times 2 factorial, which is just equal to 4 times 3 times 2 factorial over 2 factorial times 2 factorial, and the 2 factorials cancel out, which leaves us with 12 times 2 factorial, which is equal to 2, and this simplifies to 6. So for an n by n grid, we want to find the number of ways we can arrange n right moves in a sequence of 2 n moves, which is equal to 2n factorial divided by n factorial n factorial. And if we expand our expression, you can notice that we can cancel out an n factorial, leaving us with this expression. Now let's get to computing this expression. So in a new C file, we want to first include the standard IO library. Then we want to define n to be 20. Then we want a function that returns a long called count path, and it takes no arguments. Then we want a long variable called res and set it equal to 1. Now we're going to write for int I is equal to 0, I is smaller than n, I plus plus, and we're going to set res equal to res times 2 times n minus I divided by I plus 1. And this will compute the expression that I showed you beforehand. Lastly, we just want to return res. Now in our main method, we just want to print out the results of our function using %LLD, and we call count path. Now we compile our file, and then we run our file. And our answer is 137,846,528,820. And our answer was correct, guys. See you in day 14.